Okay, our last session is about a cloud programming model, a project going on in research, and we have the lead of the team, Steve Fink. So I'll turn it over to Steve, and he's going to talk about Project Whisk.
Okay, thank you, everybody. Thanks for staying until the last half of the day. And, I'm all that's standing between you and your adult beverages, but you can't leave early because they won't give them to you before we're ready. This is a talk about a research project at the T.J. Watson Research Labs in Yorktown Heights, New York. And it's about a programming model we're developing for the cloud. And it's a story which we're telling for a developer named Dave. Just show of hands, how many people in the audience call themselves developers or were once developers? Okay, almost anyone. And of the developers, is there anybody named Dave? One. You, sir, Dave, please stand up.
Hey.
Dave, today's your lucky day. Now, Dave, you and I have never met, right?
No.
But I can read your mind because you're a developer and I'm a developer. And we're like this, thinking on the same lens. I bet you want to spend time on business logic and not on infrastructure and virtual machines and servers and containers and load balancing, auto-scaling, logging, entitlement. You want to work on what differentiates your company and not on all the infrastructure and plumbing around it. Am I right?
That's right.
Yeah. I bet that the applications you build have to integrate services from IBM, open source, maybe even third-party providers, and you spend a lot of your time working on integration, getting different services to work together, managing accounts, having APIs, and you wish that that were easy.
Too much time on it.
All right, thank you, Dave. That's a good one. I bet you want to pay only for the resources you use. You don't want to think about paying by the month and for paying for things, for over-provisioning, or worrying about auto-scaling policies to pay for things. You don't even have to ask a question. And are you a mobile developer? Okay. So most mobile developers I know like to write cool fun apps. They like to do cool stuff on their mobile device. They consider the back end, the server side, the cloud, kind of boring back end plumbing. They want to spend more time on the mobile device. Is that descriptive?
This is great. Yeah, tell me more.
Today is your lucky day. I bet you had no idea when you got up this morning. I thought it was going to be a talk just for you. And this is it. So we're working on this research project on a way to program in the cloud to make Dave's life easier. And so the project at Watson is called Whisk, and I'm going to try to give you a taste of it today. Whisk, definition from Webster, is to move nimbly and quickly. This is a project around serverless. Serverless, by serverless we mean the programmer deals simply with code, not with servers, and also not with operating systems, virtual machines, containers, application servers. Simply with code. It's event-driven. We'll get into that as we go through it. It's high-level, meaning that the programming model allows you to use modern programming abstractions like composition and abstraction. So it's a fairly high-level compositional environment. I'll show you that. And it's a way to program in the cloud. So what I'm going to show you today in this talk is a taste of what Whisk is and how we can use it. So as to programming, let's get right into the programming model. There are four key concepts which make up the Whisk programming model. There are actions. I'll describe these. There are triggers. There are rules. A trigger is like an event. An action is like an event handler. A rule is saying when this event happens, run this event handler. And then we have a packaging construct for grouping together and sharing collections of these assets, triggers, rules, actions. So when we go through this talk, I should try to show you by demonstration what these things are, how you use them, and how you can build applications out of these constructs with Whisk. So let's start with actions. The most basic thing in Whisk is an action. An action is simply a stateless function or an event handler. So you simply code an action. You can code it in, for example, JavaScript. So a simple JavaScript function which produces and consumes a JSON object. This can be an action. How many people here like JavaScript? Okay, I hate JavaScript. I think it's abominable. But we can program in other languages. Another language of which we've prototype support for right now is Apple's Swift language. If you're not familiar with this, this is Apple's language for programming on iOS devices, and it's now open source and can run on Linux, so we can run it on the server-side cloud as well. So you can write actions in Swift. Let me show a little demo of using the UI of how you can define and use actions. So here we have a simple JavaScript function. And in the UI, I'm saying that this is an action. And if I click the Run It Now action, it'll upload this, install it into Whisk, and run it in the cloud. And you'll get your result as you saw in the console here. Now I'm showing you, if we want to do real programming, we need to have, for example, logging. We need to be able to pass parameters in and out. So I'm going to add a little logic to the action to dump some logs to stand it out and to access the parameters. And now when we invoke it through the UI, we can run with particular parameters. When the result comes back right in the console, we can take a look at it, we saw the logs. So just to be clear, what happened here is I'm using a browser-based editing environment to define my actions. When I'm clicking save, this is getting uploaded to the cloud in Whisk. And then when it's running in the cloud on IBM's servers, and you're getting charged just for the time that you use to run it. Here's another example of an action, which is a Swift action. It's the same, it happens to be implemented in Swift, but the programming model of the action is exactly the same as JavaScript. And you can use the same UI for running the action. And in this case, we're running Swift on the server side. So that's just a basic thing. Actions are the very basic things. They're small, stateless pieces of code, usually designed to be event handlers. I didn't talk about, I'm not going to show you, but there are other ways to define actions. The most general one is as a Docker container. Basically, if you can take any program which consumes on standard in and writes the standard out, we can wrap it in, if you can wrap that in a Docker file, extending a Docker container, which we have, basically Whisk can manage your container itself as an action. So Whisk, you can basically define any program you want in a binary. You can use any native code or C programs or libraries. Once you wrap it into a Docker file, the Whisk system can manage this just like the other actions and give you the serverless computing based on these Docker files. Another thing which is very important and gets into what we call, as far as the high-level programming of Whisk, is sequencing. So you can have a primitive action, like the code snippets I showed you earlier, or you can compose chains of these actions into sequences. And as I'll show you later on in the talk, this is very powerful. Composition is one of the most powerful things you can do in programming languages, and composing actions, I'll show you, is a very powerful construct for reusing code, especially when you start to integrate from different parties. I'll just keep going with some of the other concepts in the programming model. There's a concept called trigger. A trigger is a name for a class of events, or you might know it as a feed, although there are some technicalities as far as how we manage triggers in Whisk. A feed, as far as Whisk, trigger, a class of events, can come from anywhere. There's a HTTP REST interface for firing a trigger, so any service which can do a webhook can generate events into Whisk. So these can be social media sites, or these can be sensors or actuators. There are other ways to feed Whisk's events directly to Whisk over message queues with a Kafka-like interface and so forth, and there are even other ways. So there's a number of paths by which events can get into Whisk. The simplest is just through HTTP. And then once you install these events into Whisk, Whisk will deal with them. Another very important construct which I'm going to talk about is package. A package is you can think of this as analogous to a package in NPM, in the Node Package Manager, or analogous to a library or a package in Java. It's a shared collection of actions and feeds which you can share, which you can publish, you can share, and other people can import into their programs and use as first-class entities. So Whisk, we like to say it's an open system, it's an open ecosystem. What we mean by that is there are APIs in Whisk whereby anybody, there's no gatekeeper, anybody can define a package and say, here's a bunch of actions and triggers which talk to my service or talk to my favorite service, and you can publish them and other people can use them and use them as first-class entities in the system. So when you start to use Whisk, there's a number of packages. There are some which we at IBM have already provided. We have packages from, for example, popular services like Cloudant or IBM Watson or the Weather Company, which provide different triggers and actions. For example, the Cloudant package provides actions to read and write from a database, and a trigger, a feed, where you can register for change events from Cloudant, so you can get events generated into your program when when some other process changes a document in your database. But like I said, since it's an open API, anybody can create packages. So we've created packages for open source software like Kafka, where you can post to a Kafka message queue or subscribe to a topic as a feed. You can integrate with third-party services. I'll show you a package for Slack where you can post to Slack as an action. And then, as I said, very important that you can build and share your own. So for a particular company, you might build your own, a company or an enterprise might build their own packages of their own bespoke business-specific actions and triggers. And we think this is very important, the ability to share and customize. And there's actually some object-oriented aspects, which I probably won't get into today, really allow you to build an ecosystem without any centralized gatekeeper and a way to reuse code from many services. The final construct I want to talk about is a rule. A rule is simply a mapping from a trigger to an action. This is saying when one of these events happens, fire one of these event handlers. So I've given sort of a brief whirlwind overview of these. Let me just try to show, this is a slide saying exactly what I just said. A rule is saying once you have an event associated with an event handler. Let me go to a demo again through the GUI to demonstrate some of these things. So the first thing we're going to do here is create a trigger. In this case, I'm just calling it my trigger. So basically all I'm saying is there's a class of events. Now I'm creating a rule saying that when this trigger fires, when an event of this class comes in, it's going to run the hello world JavaScript function, which I showed you. So it's a rule. Here in the UI, it's going to go ahead and enable the rule. Now we have from the UI, we can fire the trigger. That's basically generating an event for the trigger. The event carries data. The payload is a JSON object. So to fire the event here, I'm going to define, let me pause it. So we define the payload, and then it's going to run the JavaScript action. Now, since this is an asynchronous operation, in order to see what actually happened, you have to go to our dashboard here, which is running here, and you can see the activity log of what's running, and you get a little notification at the top. We ran the hello world action because that trigger fired. As I said, it doesn't matter if it's JavaScript or Swift or any other language, the same concept applies. So Whisk doesn't care. So here I'm going to create a second rule, which says when the same trigger fires, we're going to also run the Swift hello world function. So I just enabled that. So now I have two rules associated with one trigger. When an event comes in on the my trigger topic, it's actually going to fire two events. So when I fire it with a particular payload, both of these actions should happen. And if we go into the dashboard console, you'll see some activity at the top. The JavaScript one is running, and the Swift one. So it's just demonstrating that we have two actions running off the same trigger. So this is kind of the basis of event-driven programming. It's a very loosely coupled model where you have producers of events and consumers of events, and they can be very loosely coupled. And this is an architecture, it's a structure which allows you to be very flexible in changing and building your systems, because as opposed to direct connections where the producer and consumer need to know about each other to open a socket or things like this, by having this centralized event-driven bus, you can decouple the producers and consumers. You can dynamically add more consumers to add more behavior, and it becomes a very, we heard about DevOps in the previous talk from Tamar, and this event-driven programming is a very, is one way of doing decoupled microservice-based programming and has a lot of virtues. I'll continue with this. So I showed you previously the trigger, which was fired manually by HTTP. As I said, you can also share feeds, which are effectively management of triggers, in packages. So for example, this bottom right part of the UI here is showing some of the feeds which I've loaded into this environment. I'm going to use the simplest one, which is this alarm feed. The alarm feed is simply going to generate events on some periodic schedule. It's actually using the cron syntax, if you're familiar with that. So to configure this in the GUI, I'm going to say, all right, I want an event every 5 seconds with this payload hello. So at this point, now that that's running, I'm getting these events fired every 5 seconds. I create a rule saying that whenever one of these events happens, I want to invoke action A. When I enable this rule, this is now running. There, it's enabled. And now if I go to the dashboard, now this is running continually, so every 5 seconds, I'm running the event handler A. And when we watch the activity log of what's going on, I have in Swift, we'll start to see every 5 seconds that this A action gets fired. So there's the first one, 5 seconds later we get a second one, and so forth. So that's one basic, simple kind of feed. As I said, there are others. Let me finally say about packages. Packages can expose not just triggers, but also actions. Actions are consumers of events. They're event handlers. So for example, here I've used the Slack package, which has a post. Actually, what I'm going to show you is the forecast action from weather.com, from the weather company. This is basically a thin wrapper around the REST API for the weather company. And so I'm going to configure the API here with my credentials. And if I run just this action, all it's really doing is a thin wrapper that's calling out to the weather.com to get me a 10-day forecast. Now this is a very large structure coming back from weather.com, this 10-day forecast. It has a lot of information, which is great, but it may be overkill for what I actually need for my particular application. So what I want to do is actually add some filtering logic, which would run on the server side, of course, because I don't want to communicate all this data to the client. Here I'm showing a filtering function written in Apple Swift language. This is, I'll pause it, it's cutting down, instead of 10 days, I'm only interested in 2 days worth of data. And I'm going to copy from the original structure into a structure called terse, simply the fields and the data I want from the full response. So this is a simple filtering action, which I've written and tested in isolation. When I create a sequence, whereby I pass the forecast object to this filter, effectively what I've created now is a server-side action, which invokes the weather.com API and then filters out the data I want and returns it to the client. And of course, the big advantage is that we're not communicating since we're not talking to the weather.com API directly from the client, we're cutting down the amount of data. We're basically offloading the projection operator, the cutting down of the data to the server, and just running this as a single composite action, which at that point Whisk treats as any other action, simply an event handler which runs on the server. So we ran it here. In test mode, we see that the data is much cut down. So we have just a little bit of data, and we can go to the console and we can see what actually happened. And we can see that we got the small data. If you want to dig into the server logs, you can see that we actually called the original one, the original weather.com with the large data, but that data never flew out of the server side, so it was all a server-side composition. All right, let me move on. Okay, Dave, were you impressed yet?
I'm very impressed, thank you.
Oh, excellent question. So you're asking how can you use it or when would you use it?
Both.
Both. Let me start with when you might use it, and then I'll tell you at the end how you can use it. So I showed you some demos. I hope you get from the basic picture here the basic abstractions, the basic concepts. I hope that got across. Let me try to show you some bigger demos built with Whisk to give you an idea of the kind of scenarios and situations where this kind of program starts to make sense. So I'm going to start with a mobile scenario. So I'm going to call this Whisk Weather. I showed you part of this before when I was showing you calling the weather.com API, composing it with the filter to reduce the amount. So now I'll just show you a little bit more of the programming environment for mobile. So the goal here is to add a feature using the weather forecast to an iPhone app. It so happens that this feature is for, they want to be able to deploy this for Spanish-speaking customers. So we're going to use the Watson translation service, which is exposed in the ecosystem, to do some translation. And we're going to do all the coding in Apple Swift, even on the server side. So I showed you a lot of this previously. What I didn't show you was some of the client-side mobile developer experience. So first let me show you the architecture, I'm sorry. So on the client side, what we're going to do, there's a Whisk iOS SDK and samples. So I'm going to show you, you can download those, and then you can develop your application and your Swift logic in Xcode. And then you can use a command line, if you like, as opposed to the GUI I demonstrated earlier, to upload the Swift code and install it on the server side. Also show you how to use the command line to set up this sequence of actions. And at the end, what we'll have is a mobile app, which we can stand up very quickly, which is using this sequence of actions on the server side. So this video, so we start with the experience. So once we have the Whisk command line, we say Whisk SDK install. This downloads a starter app that is suitable for opening in Xcode. So we simply unzip what we get from that, and we can open it in Xcode. What you get when you do this download is you get a sample application. The sample application is an iPhone app, which has one button, which you can run and test in your SDK. And what you get the default action when you get the sample app out of the box, invoke the date option. So I showed you earlier how to change it to do the weather and the filter. Let me show you here. Let me stop for a second. So at this point, let's talk about how you would actually do Swift coding using Whisk. Most Swift coders today are going to be much more comfortable coding in Xcode. So in this case, what we've done, the typical flow of how we imagine we do this, is we would prototype and debug the Swift logic on the client side. And then eventually, when we're satisfied that it's functional, we just want to move it to the server side and compose it with our action sequence in the cloud. And that's what we're going to do. So I already showed you in the GUI what it looks like in the GUI. You can do the same thing directly from your, oh, I'm sorry, this is going to restart. That's all right, we'll just let it go. What it's going to get to in a minute is it's going to show you from the command line that you can upload your code, which you've developed in Xcode, directly from your Xcode environment up to a Whisk action. So we'll get to that in a minute in this video. As I said, out of the box you get, it's calling this util.date. This is a built-in action which you get from Whisk, which gives you a date. Once you change your app to invoke your own action, and we've developed the Swift filter on the client side, we'll simply upload it and move it to the cloud from the command line. The command to do this happens to be Whisk action create. We call it filter, and we simply use the path that we used to develop the Swift code in Xcode. Now we have an action. I showed you earlier how to compose in the GUI. Here I'll just show you can also do composition for the command line. So in this case, I'm taking a sequence which we developed earlier in the GUI, which was called myForecast, and I'm going to enhance it to, after doing the weather forecast and the filter, we're actually going to pass it through a Watson language translation action, which is in the catalog. And when we update that sequence, we've updated the server-side functionality. If we test it now, we get our results translated into Spanish. And we actually didn't have to do any changing at all on the client side because all the logic changes were on the server side. So once again, part of the story here is decoupling client-side coding. It's all, as Tamar said, it's about decoupling, breaking your development into smaller pieces. And here we're trying to decouple all the server-side logic from the client side and make it as easy as possible to operate in both environments as you need to. Let me show you another example, which is not a mobile app, but this is a web app. So the motivating case here is we have a traditional web app implemented in something using Node.js, and we want to enhance it with extra server-side functionality. And in particular, this is an image sharing website. We're going to want to generate thumbnails for upload images. We're going to want to do image tagging on these uploaded thumbnails. And we want to engineer this as a cloud with cloud-native microservices. So we want it to auto-scale, instantly run in parallel. We want it to be reliable. We want to pay only for usage, and so forth. So let me show you the architecture of what that looks like. So the development process here, imagine we start with simply mocking up the website to show what you want. So we'll start with simply a Cloud Foundry Node.js web server which was talking to a browser, which simply to work on the presentation logic. And in this case, what we're going to do is we're going to do all the data we're going to store in a cloud and database. And so from the front end, for the presentation and from the web app point of view, all it has to do is insert data into Cloudant and then read data from Cloudant and then present it. And then from the web app developer's point of view, maybe there's some magic that happens in the background to automatically populate the Cloudant database with the value add, with the data we want to share, show, which enhances our application. What we're going to do is we're going to implement that value add magic using Whisk as an event-driven system. So in particular, what we're going to do is we're going to set up two rules in Whisk. One of them is we're going to say, all right, we're going to use the Cloudant package to say, when there's a change to my Cloudant database, in this case when an image is uploaded, I'm going to have two rules. One rule is going to call an action which we wrote to generate thumbnails and store them back in the database. We'll also, in parallel, at the same time, we'll install another rule, which is listening for the same events, which is going to call Alchemy API, which is a Watson visual recognition service, to generate tags for the images and also dump them in Cloudant. So we have the web app front end, which is simply reading and writing from Cloudant, and then we have event-driven logic driven off changes in Cloudant, which invoke third-party services to generate thumbnails and generate tags using Watson and put them back in Cloudant. So again, we're on this theme of decoupled application architecture. And the result, just as a demo, is like this. You upload your images here. The web app has dumped them in Cloudant. Here I'm just showing you can poll. You can take a look at what's going on the Whisk side. It's running all those rules. So if we uploaded 10 images, it's actually running 20 rules in parallel. It'll instantly auto-scale to service these 20 requests in parallel, calling out to the services as we built. And getting the final result very quickly. And as you can see, my favorite part is the image analysis correctly identified my kitten burrito as food. So, one final big picture demo is something we call Git to Slack. So we use Git and Slack in our development. We love Git, we love Slack, but we wish we had more out of it. They're the built-in integration. How many people here in the audience are familiar with Git and Slack, both and use them daily? All right, so Git, we all know Git, I'm sure. Slack is think of it like internet relay chat for the millennial generation. It's a really slick communication social forum oriented for developers. There are webhooks you can get which will post where you can, integrations where you can say, when there are changes to my Git repository, send messages to Slack. That's great, but in our case, what we want to do is we want to actually customize this integration. We want to suck in other services to do more information. I'm going to show you how we can use Whisk to do this very simply. The structure of this architecture, once again, we do this completely as an event-driven. So we've published, in Whisk, we've already built a GitHub package and a Slack package. With the GitHub package, you can configure and listen to GitHub webhooks as events. And what we set up here is a chain of actions, so that when we get an event saying that there's been which is basically a webhook from GitHub, saying there's been a commit to our repository, we do some application-specific filtering to put it into a format we want. Again, in this case, we're going to reuse, since we already showed it, reuse the IBM Watson language translation as an event, as an action, and then we'll use the post to Slack action, which we can configure and set up to post to our Slack account. And the result, in our case, in this case, just as a little demo, is we get a customized Git to Slack integration running in the cloud, writing very little code. In this case, it's actually posting the commit messages in both English and French to make life easier for our development teams in both England and France. I'm almost done. So in summary, as we said, Whisk lets you concentrate on your business logic. You could think of Whisk as a very high-level platform as a service, significantly higher level than Cloud Foundry, for example. It's an event-based programming model based on actions, triggers, and rules. It's designed in particular to allow you to produce and consume services, whether they're from IBM or open source or third-party providers or from your own enterprise. And the way it accomplishes this with a standard package API and catalog, whereby anybody can create and share packages and use them. So we hope to build a big ecosystem of pluggable parts here. Effectively, think of Whisk as a platform for doing mashups, and packages are the things you can mash up. I didn't talk about billing very much, but much like other serverless things, you get the billing model here is you pay only for the resources you use. So if you're basically, whenever an action needs to run, we'll provision resources to run that action, and you can charge only for the amount of time while it's running. So if you have an application which, say, only needs to run 1,000 actions per month, and each one runs for a few milliseconds, you'll only get paid for a few thousand milliseconds, and you don't have to provision things by the month. Also, we saw the instantaneous transparent autoscaling. So in Whisk, you don't configure an autoscaler or define autoscaling policies. It's completely, the system handles all the scaling and load balancing transparently, and it happens instantaneously, very fine-grained. I also showed you, we're definitely trying to target mobile space, so there's the iOS SDK. We're supporting Apple's Swift language on the server side, and we think it's a really great platform for writing mobile apps in particular. So that's pretty much it. Dave had one final question which I didn't address, which was how can he use it? So as of today, Project Whisk, as I described, is simply an experimental service we developed as a research project. I'm not going to announce its availability today, but I will say that very soon we're going to have means to have an early access program. So if you want to try to get early access to be an early adopter, please just see me, either send me email, you can find me, or come see me after the talk, and I'll be happy to talk further with you. That's it, I'm done. I'll just leave it open to questions now.
Question up here.
Yeah. I think you touched on a few of these points, but how does it compare, or are there different design decisions regarding similar approaches like if this then that, or AWS Lambda and things like that? Do we have different, fundamental different design decisions, or is it kind of a similar approach here?
So the question was, how does this compare to if this and that or Amazon Lambda?
Yeah.
So it's similar in the space that all three are in this serverless event-driven model. I would say, if you look at the programming model of abstractions, so for example, compared to Lambda, we're probably adding some higher level programming constructs, such as the composition of actions, the ability to, the API to expose and share packages, the ability to run things in Docker containers and so forth. IFT, on the other hand, really isn't customizable. You can't do your custom logic in IFT. IFT is very nice. I would say IFT is more targeted for end users, and I would say we're targeting more for developers. The question was, does WISC support transactions? And the answer is no. There's no guaranteed concurrency model. There's no ordering model. If you want transaction behavior, you have to use other software which takes care of the transaction.